Okay, so for section 5.2, we're going to be dealing with integration that involves natural logarithmic functions. And here's the log rule for integration. If you're trying to integrate 1 over x with respect to x, we know that 1 over x is the derivative of the natural log of x, right? So the integral of 1 over x has to be the natural log of x plus c. Now, they don't make you put absolute value when you take derivatives, but they do for some reason with integrals. And the reason is that in the derivative problems, the natural log was in the original problem. Does that make sense? And so you can understand that if it's there, then it only works for the x's that are positive. But in integration, since you introduce the natural log into the problem, you have to put absolute value there so that the reader understands that the original could have been any x, but the final answer can only be the positive ones. So it equals the natural log of the absolute value of x plus c. It also works for things that aren't just x. If we want to integrate 1 over anything, as long as we sacrifice the derivative of the bottom, then that will equal the natural log of the absolute value of whatever was on the bottom plus c.
Why is C capitalized?
Why is what?
Why is C capitalized too?
Because I didn't type it well in the first one. Typically it is capitalized. I guess I just forgot.
I didn't know
I'll
that.
pause for a second, let you take any notes you need, and then we'll look at some examples. It's not a bad lesson. Okay, so for our first one, we have the integral of 2 over x dx. And the best thing you can do with these is just treat them like you would any other integral. So if I were just going to try to integrate this, I would rewrite it as 2x to the negative 1 dx, correct? Okay, and the 2 is just behaving as a coefficient, so I would just keep the 2. And then here's the thing though. If I try to add 1 to the power, what power do you get?
0.
Which is not a problem. You know, it's okay to have a 0 power. But if you tried to add 1 to the power, you got 0. Here's where you get into trouble.
You can't divide by 0.
You can't divide by 0. So the question becomes, what do I do with this? So when you find yourself in the situation where you're attempting to do the power rule, and you add 1 to the power and you get 0 power, and then you're thinking, oh, I'm trying to divide by 0. That is your cue that it's a natural log problem. So they're very easy to spot. You don't have to spot them going in. You just treat it like you would any other integral problem, but when you add 1 to the power and you realize that it's going to 0, you stop, you keep whatever else is there, and then you just put a natural log of what was to the negative 1 power. But make sure you put an absolute value, like this. So that's your cue. When the powers 0 out using the power rule for integrals, that's going to be a natural log problem. Whatever was attached to the negative 1 power will become what's after the log, and you'll put the absolute value on. Now another way to write this, you could stop there, but sometimes your book would write it this way. They would bring the 2 to the back. And the reason they do that is once I square it, it becomes positive anyway, and I don't have a reason for the natural log. So either one of the, I don't have a reason for the absolute value. So if you leave the 2 in front, you have to leave the absolute value on. But if you move the 2 to the back, it forces whatever's there to be positive, and there's no need for it anymore. So either way, how would I check this? You would check it by taking the derivative. Let's see if that works. The derivative of this is 2x over x squared, which is indeed 2 over x. Yeah. So you could always check them at the end, and they should go back to the original. Let's try another. Here I have the integral of 1 over 3x plus 1 dx. So we're going to bring the entire bottom up to the top. We can't split it up, but we can bring the whole thing up and treat it like a parentheses to the negative 1 power. So here I'm attempting to integrate a parentheses to a power. Before I can do that, I have to reverse the chain rule and give away the derivative of the inside of the parentheses, which is a what? 3. But I don't have a 3. But I can make one up, and I can put it over here with this dx so that I can give it away, and so that will allow me to apply the power rule and to continue to integrate. But if I introduce a 3, I have to balance it by multiplying by a
1/3.
1/3. Okay? So now I'm allowed to continue integrating. So I have 1/3, and then if I attempt to add 1 to that power, you notice that it zeroes out. So anytime you're integrating a -1 power, it's going to become a natural log. So this will become the natural log of the absolute value of whatever is inside that parenthesis plus c. And there's your answer.
But it's not always going to zero out.
It's not always going to, well, if it's a natural log, it's going to zero out. If it doesn't zero out, you just integrate it as we have everything before.
So could you rewrite that as the natural log of the cube root?
Yes, you could rewrite that as the natural log of the cube root of 3x plus 1. But you would still need absolute value on that because cube roots can be negative. So, either one of those.
It's only positive exponents that can always be, but always.
It's only even.
Even.
Yeah, even radicals and even exponents are the ones you wouldn't need absolute value on. Let's check it. It's easier to me to check from here. So let's see, keep the 1/3 and then take the derivative of what's after the log and stack it over what's after the log. What happens to the 3's? They cancel, yeah. Just like they kind of do here when I introduce them. And that leaves me 1/3x plus 1. So it does check out. Always check your answers. Okay, for our next example, we have the integral of x over 5x squared plus 3 with respect to x. And I am going to rewrite that by bringing the parentheses to the top. And anytime you have a parentheses to a power, with integration, you have to give away the derivative of the inside of the parentheses. Well, what is the derivative of the inside of the parentheses? 10x. So, I'm going to rearrange this. Move my x back here with my dx. And all I'm missing to be allowed to integrate this is a 10. So you must sacrifice a 10x to the integral value so they will allow you to integrate that parentheses to a power. So if I make up a 10, I can also put in a 1/10. This is gone. And then I can try to do the power rule, but you realize with a -1 power, it's not really going to be the power rule, it's going to be a natural log of an absolute value of whatever is to the -1 power. So that will become what comes after your log.
squared plus 3
Right?
plus c.
Plus c. So you could stop there. Or if you really wanted to do something strange, you could do the 10th root.
And it wouldn't need absolute value.
Nah, usually we don't put those on even radicals.
So you
But
don't
if you still put it there, I wouldn't count off, but usually they're not going to be there. Did somebody else have a question?
yeah, so you don't use the negative like usually whenever you do like the chain rule or the power rule, you use the -1.
To divide by?
Yeah.
Well, no, because if this actually isn't a power rule problem, because if you were going to do the power rule, it would become to the 0 power, and that's what you would divide by. But this isn't a power rule problem because when the -1 is actually the natural log. That's how you know that the natural log has entered into the answer. Did it make sense? Okay. One more, and then we'll stop. Let's look at the integral of 3x squared plus 1 all over x cubed plus x with respect to x. First thing we need to do is rewrite that. We'll keep the top. We'll bring the bottom up to join it. So we'll write the bottom to the -1 power. And then anytime you have two parentheses and you can't distribute because one of them has an exponent on the outside, your hope is that one of those parentheses is the derivative or a piece of the derivative of the other. So if you imagine that this is your u, what's the du? 3x squared plus 1, right?
Mm-hmm.
Well, that's really nice because that's exactly what I have here. So these guys together act as your du. So if we rearrange it as x cubed plus x to the -1 times 3x squared plus 1 dx, this can be my parenthesis and this can be the derivative of my parenthesis. So that can be my sacrifice, right? So I give away I have exactly what I need to give away to reverse the chain rule and to appease the integral gods. So that's gone, right? Okay, and that allows us the right to integrate this. Unfortunately, when we have a -1 power, the power rule doesn't work. But that's our cue that I don't need the power rule, I need to put a natural log. So it's going to be the natural log of the absolute value of x cubed plus x plus c. Then, of course, we should check. Let's see. It's the derivative of what's after the log divided by what's after the log. And sure enough, it takes me back to the original. And I think we'll take a break right there.